Okay.
Sure, go ahead.
Okay. Hi, my name is Meredith, and this are my group members, Tanya and Rosa, and we are part of the company called Envirostryke, and our product is CyanoClean. Oops. The problem that we are focused on is reducing the amount of heavy metal pollution in water. To help you understand the seriousness of this problem, 1.2 trillion gallons of sewage and industrial waste is dumped into lakes every year, which is about the amount of water the United States uses alone in a year, or 2 million Olympic-sized swimming pools. Also, there are about 180,000 acres of pollution that also go into lakes and streams every year, which is 720 million square meters, which is like a huge amount. Like, this is just 1 square meter, and there's 720 million of those. So we, the pie chart at the top displays the different places where we get the heavy metal pollution, and mining being the major and urban being the least pollutant. And the chart also shows how the heavy metal polluting levels are increasing almost exponentially over the years.
Our product is a genetically modified spirulina patosis cyanobacteria, and we plan to insert 5 different genes. MER A and MER B, which will reduce mercury level by converting it to a non-toxic form, RC, which will also convert arsenic into a non-toxic form, and ACCCS1 and TACCS1, which will reduce the level of carbon and zinc in the polluted water. We also plan to add a kanamycin resistance gene, so we can grow it in a media that has kanamycin to prevent other bacteria from growing.
Okay, so we basically took advantage of a naturally occurring process called bioabsorption and amped up this ability within the bacterium. Essentially, this is a process of passive cation uptake by the cell walls of dead or living biomass. And we plan to sell our product within these dialysis-like pouches, which will make it very easy to extract it out of the water once it has done its process. So this is a general overview of how everything will work. Once we grow these modified spirulina in bulk, we will place them in our pouches, and after that, all you have to do is place the pouches into the site of contamination, take it out once it's cleaned up, and we'll take it to a metal extraction or detoxification plant. So currently we have 2 potential customers we hope to bring our product to. The first is towards environmental remediation companies, and the second is for companies that actually cause the pollution, such as oil and mining companies. And up here is a table of current processes out in the market, and as you can see, a lot of them use technology, chemicals, resins, or other compounds that are either difficult to obtain or simply expensive. I believe our product will be able to gain a good footing in this market because of its simplicity and low cost. This is due to the fact that our product mainly has 2 components, the modified bacterium and the pouches. Literally, it is a cyanobacteria in a bag doing the same exact job as all these expensive chemicals, resins, and other compounds.
We plan to protect our property using a utility patent, and right now there are 3 competing patents. The first patent cleans heavy metal from water using cyanide and electrochemical cells. We don't use any of that. The second patent cleans organic materials from polluted water, and we don't clean organic materials at all. And the third patent cleans mine and polluted water through chitin-containing materials, which we also don't use. Ours is better because ours is environmentally friendly because spirulina grows naturally in water, and it doesn't leave any chemical or toxic residue.
So we have to make sure that our product is approved by the Environmental Protection Agency, which we have checked all of the regulations and are positive that our products will be more of a benefit than a problem to the environment. And here's the references.
Great. Thank you very much. I'm so excited. I see guys want to just ask the questions.
That's how it works.
Okay, so how many times do you have to remove the bacteria in the lake for this
It'll depend on the size of the contaminated area. If it's a large size, we might have to change up our pouches and maybe create a larger one, which would mean that we don't have to continuously take it out of the water and put it back in. So it just really depends on that, and we'll change our pouches depending on that.
Assuming an average size pouch, an average sized body of water, how long will it take to clean it of heavy metals to one where we say working or something, roughly speaking?
Right, so bioabsorption is actually a very quick process, and it can actually, when they did an experiment in lab, it took about possibly half an hour. So for a larger body of water, I would assume maybe, I would give it about half an hour to an hour.
Well, that's not
How big are these patches? Are these bags, and what are they made of?
Again, it depends on the body of water. So if we want to sell it, let's say in kitchens, we can make it smaller size. But if we're aiming for a larger lake, we will make it larger. We'll change it up.
This big or pool size or
We plan
tea bag?
tea bag. We will not necessarily full size. That won't be too big, but possibly half the size of a person, and then instead of just creating these huge bags, you can just do it area by area.
Good. Anything else? One more. Quick one.
Wouldn't smaller bags be better because it would increase surface area, like cells?
Yeah, that's why when we're aiming for the larger bodies of water, we don't want to make it too big, but at the same time, we don't want to make it too small because that would mean that we would have to create a whole bunch of these all like little ones, and it might make it difficult to take it out of the water. So again, everything just depends on the size.
Sounds great. Thank you very much.